Hey, Paul, welcome back.
Thank you. Good to be back again. Third time.
Yeah, and not the last time, because more and more happens. You are also crazy busy, so who knows what happens.
Who knows? Yeah.
Today is the Valhalla day.
That's right. There's a lot going on there.
First question, why the name? I can already imagine, but...
You'd have to ask John Rose that.
Mhm.
I'd have to look back. Something around, or, I don't know. I'd have to get back to you on that one. I can sort of make something up, which may be approximately right, but I don't want to get it wrong. So
Okay.
dig through the archives. What's that bridge that leads to Valhalla? You know that guy with the sword in. I can't remember, the Bifrost or something like this.
Okay.
There's something related to that as well.
And I thought Valhalla because Val like value. This was.
Well, there's probably that aspect of it as well.
Okay.
It's a riff on the name, but there's something connecting with the Viking lore as well, perhaps.
Wow. Okay. So a deeper meaning than that.
Yeah.
But basically, it's about value objects, right?
It's all about values, and trying to design that into the platform.
And so, interestingly, in my boring enterprise world, the value object, there was a value object pattern, and the name was wrong, and no one noticed that for several years. And then someone said, "Okay, value object is a wrong name." And and there was like a mass discussion on the internet. Okay, this is what we should do about that, and it was renamed to data transfer objects. But I think for 3 years, everyone talked about value objects, and then you say, okay, what are value objects then? And this was, I think, it was like 10 years ago, and the value objects basically back then were in domain-driven design. Objects where the value was more important than the reference. So this was the definition. And for me, it was always like an enum. If you have an enum, it was like the enum is a kind of value object. But Valhalla goes further than that, right? So this was what happened now without even Java support. There was already a lot of discussion what value objects are. And
And in fact, Java developers have been using values since Java 1.0 came out. They're the built-in primitives where you may not attribute the name to them. Those are values. An int 42 is a value, and you can only have one of 42 around. And you get all the optimizations that these things give you, but they were not afforded to references. And so we want to... Brian Guts came up with the mantra, I think, codes like an int, behaves like a class. So we should be able to write our own custom sort of class definitions that behave like a built-in primitive int in terms of the optimization capabilities given by the platform. But to do that, you have to give up some stuff. To become a value, to have your own value, you have to give up some stuff. And that's the challenge in Valhalla, is being able to determine the programming model that allows you to give up successive sets of stuff to get increased degrees of optimization. It's actually remarkably complex what goes on underneath the covers, and it's actually quite hard to explain it in a coherent way without getting tongue-tied, because there's sort of various levels of giving up stuff.
But the enums, as we know them, they will become values in Valhalla after Valhalla, or after Valhalla is introduced, or how to?
Well, that may be challenging for backwards compatibility, because depending, because when you write, I think enums are potentially a good category of existing things that could be turned into values.
Okay.
A bit like we already have in the JDK things that could be turned into values that we marked with an annotation or some description in the Java doc called value base, which is, these are candidates. We can prep them up ahead of time. And if you do things that on them that you assume they're references. Please don't do that, or we may introduce compile time errors that detect this. Great examples of these are the integer, character, all the boxes.
Mm-hmm.
And enums may be a category of that as well. But enums have, in fact, the enum value that you get out is a reference, because references are values in Java. That's a classic interview question. But you often compare the two things using identity.
Mm-hmm.
And that is a problem with, because values don't have identity.
Mm-hmm.
And so you're comparing the contents of the value. You're not, and that's where enums are problematic, because you often think of these as constants, but the equality, you're comparing a reference of this enum to a reference of that enum. If they're equal, they're the same thing. Otherwise, they're not, in terms of equals. And that's problematic from value. Use of
So,
value.
will I get a compiler error in Valhalla if I try to compare two values with equals?
Yeah, I believe actually we will be retrofitting equals to do structural comparison instead.
Okay.
So the actual acomp bytecode will be enhanced to compare values by their contents or structure rather than their reference.
Mm-hmm. So maybe we should start with with the question, why would like to have values at all, right?
Yeah.
Because there were a long time without values, and now we are talking about Valhalla. It's not new stuff. I remember even the first Java ones, Oracle's Java ones, we already had the keynote Project Valhalla was introduced. So it was when it started, you remember this?
Probably a decade ago, maybe more than a decade ago. And I think even then, before James Gosling was thinking about values and the performance advantages they give you. Even before then, and he recognized this as a multi-year, multi-PhD kind of project. And it's turned out to be that way because the problem is hard to get right and to fit it into the Java language in the way that it looks like it's always been there. That's our challenge, is to make it look like it's new, but it fits in and looks like it should have been there from the get-go.
Yeah.
Plus or minus some rough edges, because we can't avoid those types of things.
But if James Gosling would start with values from the beginning, then it would be easier, right? So the challenge is retrofitting the concept.
Yeah, perhaps that's so. If he got it right, which is a good chance, he got it right. Then it would be easier. But I think the challenge at the time, like maybe 15 years or 20 years ago, the computers didn't have such sophisticated levels of memory and caching associated with them. So this idea of pointer chasing, where you jump from a pointer references, wasn't so much of a problem for building up modeling stuff in Java. And we had the primitives, and we could get away with that. But as the years passed, it becomes more of a problem because the computers got more sophisticated, and the class level abstractions we have make it harder to implement efficient code the way we want to implement it. And we've always had to sort of distort the code to make it optimal, rather than writing the code we want to write. So you can think of Valhalla as writing the code you want to write that should be optimal rather than distorting it. So an example would be if you had like a notion of a struct, and you had an array of those, for example. Often they know that you get an array of references, but then people tend to say, well, my struct is an int, and a double, and they have primitive arrays of int, double, as separate things, which distorts the model that they want. When they really want is an array of something that flattens out in memory, and that's what Valhalla will eventually give you, is a way to express a class.
Flattens in memory, the term, I also read it. So what this means is instead having an array of pointers pointing to several pieces in memory, you have a sequence of values in one piece, in one block.
Yes. So if a value has an int and a double field, value class is an int and double field, and assuming you've opted into the right level of constraints in the value class, and you create an array of that, then you may find that in memory, it just so happens to be an int, double, int, double. So that'd be 4 bytes, 8 bytes, 4 bytes, 8 bytes. And with assuming alignment constraints and stuff like that, you get this flattened sort of sequence. And that is, of course, very useful, very optimal from the way the memory hierarchy works of the chip, because it can preload in and you can do vectorized operations on it and so forth like that. So that's what that gives you. It gives you the behavior of what an interarray gives you for sort of compound classes with multiple fields inside them. Now, that's called heap flattening. And that is a very powerful optimization for those that want it. But there's also another kind of flattening, which is on the stack. And runtime already does this to a certain extent, but it's constrained. It's called scalarization for escape analysis, which means if I allocate something on the stack, which means I allocate something and store it in a local variable, and if it doesn't escape out, or I don't do any forms of operations that expose its identity, it means you can scalarize it out into its fields and store them in registers on the hardware. But it's very fragile. And now we have value classes. That fragility goes away, and you can do that operation reliably. So not only do we get flattening on the heap, we get flattening on the stack, and then we get flattening across method calls through that mechanism as well. And so we can explode and do that. So rather than passing a reference to my value class of double, int and double, I can pass the int and double directly as arguments to that method, so I don't need to allocate it. It's all about reducing allocation on the stack and reducing pointer chasing on the heap, if you like.
Is it all about speed and performance, or something also about developer experience? So
I think there's a lot of it is driven from performance and the better and the most optimal way to use the computers we have today and in the future. But I think it's also when people lean into using, say, like records, like data carriers and stuff like that. There's a model there of why you might want to use a record as a carrier for your data, and those fit very well into values. And so if you have a record and you don't need identity on that, then you can make it a value. And then the VM is afforded options to optimize that. But you've also opted out of identity because you don't need it. And you've opted into a model of your data, which is clearer. I think so. I think it can help in that regard as well when you think more data orientated in your design, as well as optimization side of stuff, which I think will take as the mental models that developers build up, they have to sort of build up a new mental model of these things as they go, and as they build it out in their head, and we help them with that, they'll get a better understanding of where to use these.
This surprises me a bit, because what I thought is that records become always values, because what is the use case for having identity records?
Let me think. It's a good question. I think a lot of the time records will be values, but there's cases where you can't have values, which, for example, if the record references itself as a field inside itself, you can't represent values, cannot reference themselves as values inside themselves. Otherwise, you get an infinite recursion because you can't flatten it out. And so that's one use case. You may have a linked list where the record refers to a previous or next inside itself, and unless they're references, you can't express that using values.
Yeah, you're right.
So there's actually a way to do a combination of these two things, but that's one use case where you may not want it. Another is backwards compatibility, because someone is synchronizing on these things.
But nested records would be possible with values, right? Nested records are possible as values.
You can, but you can't reference yourself.
Yeah,
as a value.
Yeah, but nested is not a problem, because you can
nested is not a problem. So you can have you can model a structure. Imagine in C, these values aren't structures because the values are immutable, just like records are in that case. Because you can't, if you mutate a value, well, are you mutating all of the 42s in the world, or are you just because they have no identity? You can't mutate the thing. But you can have like the equivalent of C, structs and structs. You can have classes in classes, and potentially it can all flatten. It depends very much on the VM and the size constraints in flattening, because it may not make sense to flatten everything because it may be too big.
By the way, the other day I worked with an enum, and I had a set of so a broader enum with a constructor and some values, and I had a set of constants, right? And then I thought there was a use case, and I needed the last constant has to be flexible. It was depending on environment, and I said, okay, this is not doable with enums now, right? So everything was beautiful and didn't work. And the surprising part was I converted the enum into a record, and it worked perfectly, right? So records are very similar to enums, and it didn't occur to me, So I worked with enums a long time. Now we got records recently, and they are very similar. So records are kind of mutable, and if you have a record, and inside the record some constants, with predefined records, it's almost an enum. Of course, I don't have an enum set. I don't have, the values method, but behavior is very similar.
Yeah, you can emulate that.
Yeah. And this was surprising, not surprising. I mean, this is obvious to you, but for me it was like accidentally. I said, okay, this is actually the perfect case to misusing records as enums, where I can predefine,
Yes,
a set of variables, and the last one I can configure from outside, So
Yeah, there's another interesting surprise that people may find with records. The records can implement interfaces, and if the interface name is the same as the accessor, then you can do that. And that's actually quite a powerful trick. Now, I would say that's not an abuse of modeling in this case. It can actually work to your advantage.
Okay, so they can implement interfaces. Yes, this is the data-oriented programming thing, So this is what you can do. Then you get a type and have a switch with expression. But what you said right now is that if you define an interface, the accessor method, right? What is the trick here? What's the pattern?
Well, because the record has components, and the components have names, and those names are exposed out as methods.
Yeah.
And so if an interface expresses an abstract method of the same name and return type, then the record can implement that interface without having to declare the methods that it's implementing. So they just correspond to the component accessors. And sometimes that actually works out quite well as a technique.
Okay.
So if you want to abstract out some of your record and expose out your interfaces, which is a common pattern we've applied in the JDK, is to implement records but not expose them out, but expose out the interfaces they implement, so we get a bit of flexibility in our implementation.
Yeah, so I actually did it accidentally because and enums can also implement interfaces. This is also the crazy part. So I implemented an interface. So enum and record implemented the same interface. I could expose an accessor method. Enum had to implement this, but in record was already there. So I mean, this was part of the component, what was in the constructor. This is really nice. I mean, this is
it's a good modeling technique. I think records initially were a little bit sort of, this is just syntactical sugar, but it's not really. It's a different way of modeling data, and I think it leans very much into how developers might think about that for values as well.
And what I use or misuse records is as a grouping of parameters. If I have a lot of parameters, they belong together. So what I tend to do is I define a record combines all the parameters and use it as a method parameter. And this record, so it is easier to read. It improves the readability, but I could also have some validations in the.
Yes, that's right.
Yeah.
It's a bit like a nominal tuple.
Yes. Yeah. And what I also tend to do is lots of factories. So static factories which creates records. And so one thing what I did. This is now a question to you, is also off topic. I had a record. But one parameter was optional. So I use optional for that. It worked perfectly, but I had really bad feeling because it didn't look right. I have a record with two components, and the last one was optional one. It worked perfectly because it could be set or not, and I ask the record, is it set or not? So it worked for my business case. It worked perfectly, but usually I never use optional as a parameter. So what.
I mean, my thought here is if it worked for you and you're happy with the design and you don't feel it smells, then all good for you.
Yeah, I never told to anyone. You are the first one who's like, so what's your take on that?
there's no shame in that at all in any way whatsoever. I mean, that kind of makes sense. And, we've been sort of, I think Stuart Marks had some very good advice on the usage of optional. He wrote up somewhere, I think. But, one of them is not to use optional in fields. It's not recommended. But I think this is slightly different because you're using optional with a component, and that type is exposed out. So even though internally it's a field, it doesn't matter. What you're modeling is some optional parameter of the record. And so what would you can either use null and document null, or you could use something with a clearer semantics of something that is there or isn't there. And so I think that's clearer from your design.
Yeah, perfect. Thank you. So it looked strange, but it worked good actually. So
and in fact, we'll be able to turn optional into a value, and that's really good because usually you don't store optionals on the heap, but in your case, in the record, it will, unless unless your record is a value, and then the components are scalarized, so they come on the stack, or something like that. So your records you may not have an array of records. Your record may just be a local variable created. It may not even be stored in a field. But optionals will be values as well. And then they'll be highly optimized by the runtime. So we're all reducing allocations on the stack by quite a bit for people who are using optional heavy code. And I think people will see benefits in reduction in GC cycles because of that. That's one of the main benefit I didn't at least think of at first. I was totally focused on heap flattening. But there is stack flattening and method call flattening. And stack flattening and method call flattening have benefits on their own, especially for temporary data. Data on the fly, like optional or records, grouping things together and all that. They often don't get stored in the heap. And so if we can reduce the allocations of those things, it gets...
Why optional is not stored on the heap? Because it's a reference? Or
well, you may store it on the heap, but it's often used as a sort of temporary value. Not in your case in records, potentially, but often... if you don't recommend using optional as a field, but expose it out as a method,
so optional of nullable. So this is like a temporary one.
Yeah.
Okay.
And so those will get optimized away much more cleanly than before. And another related to that with Valhalla, we'll be able to improve the efficiency of the boxing unboxing conversions as well. So they will get optimized. So we don't have to worry so much about those kinds of conversions that are happening on the fly, not on the heap, but on the fly like that. And I think we'll see benefits like that come into code. And that we'll predominantly see that in hopefully larger applications with less GC cycles going
on. So we get new keywords, probably. Value, identity, and regulated constructor, I think, right?
What is it? it's let me look. I had an email prepped so I can see. I was just looking at the constraints. Brian wrote a very good email the other day on the Valhalla dev list, which said the mental model for Valhalla project has been a bit like the Spanish Inquisition sketch in Monty Python. I don't know if you're aware of that, but it's sort of like the main impediment is identity. The two main impediments are identity and nullity, and implicit constructability. Amongst the impediments to flattening are identity, nullity, implicit constructability, and atomicity. You see the sort of logical thinking that goes on. There's more here than we would ever expect and developers would ever expect. So value is a keyword. I don't think we need identity as a keyword in that respect. It may be there's a modeling question over keywords or interfaces. The implicit constructability will, I suspect, require a keyword on the constructor which says I'm implicit. It means you can construct me without going for a constructor, which means what we get is a zero. If you want to construct an array of something, well, what values do we give it for the default? Zero is a wonderful default, so if you want that, you need to opt into implicit.
So nullability is also part of Valhalla?
That's correct as well. This was another surprise. Initially, maybe we didn't think this was as important, but it turned out no matter how we thought about it, we can't avoid the aspect of nullability here. So this is something that we're going to have sort of, what are they called? I guess type constraints or something of this nature to describe that a type can hold a null. A value of a type can have null in its set or not. And that's important for flattening as well, because if something has null in it, then you've got to have an extra bit or something that describes, am I null or am I my contents, which makes it harder to implement flattening. And so nullability is coming out to the fore in a way to describe this constraint. And that, I think that has huge advantages just outside Valhalla.
Yeah.
In terms of being able to express what's null and what isn't without your formally in the language and not in the Java doc or in some annotations outside of the platform.
So will we lose the null? This will be no backwards compatible.
I think null is a great thing. It's just that it sometimes is all we have right now and it gets in the way of things. But I think sometimes it's okay for things to be null, and you don't have to use optional, because null is it can be a good way of describing something that's not there. But to lean into it like we have had to do is problematic. And being able to express whether it is or isn't, I think, is a great thing, especially for API design.
So what will be the difference now? So now I can use null or optional, which is not a language construct, more library, right? So what do we get after Valhalla?
You mean if you have a value class that you say that it's if you have a value class that describes a value type, and you say that this type cannot have null in it, then if you create an array of these things, you get better flattening.
Okay, but we need a keyword or something
we need something to extend the type system to describe a nullable type or a non-nullable type, or a property that this type has been augmented with non-nullability or something like this. I can't remember the exact terminology that's currently being used.
But I can still say something, a string name equals null, right? This is...
yes. It won't be removing anything like that from language. So there's actually three things. Either you have a type and you don't know whether it's you don't know what its nullability constraint is. It could be either or. You have an explicit, this thing can contain nulls, and you have an explicit, this thing can't contain nulls. And you have these three things, and we can describe all of those three things in the language. The challenge is backwards compatibility, and the challenge is generics, and how you describe a type variable of that constraint as well, and how you flavor through this. Every time you deal with the type system here, it's particularly challenging to get right. So other people in Java platform group would be thinking quite heavily about this.
You wrote a lot of Java code, I guess, right? I
have, yes. Thrown away as well.
Maybe even more than written, right? So
this is probably correct.
Yeah, this is also my case. But have you a lot of problems with null pointer exceptions?
I would say I've run into it enough that it's frustrating.
Okay.
I would like to design my APIs with more clarity about what can be null and what can't be null. And optional is not the solution to all of those cases at all. You really want to lean into the language and platform for this. So I think it helps a lot to describe at your boundaries of your calls what you can do. I think that's going to be probably the biggest benefit from an API design point of view. And then the runtime follows through with that and leans into that. So when you're designing a value class, you go, well, I know I'm not going to have identity. So the next question is, do I want these things to contain null or not? And you go, no, because it doesn't make sense to me, because I'm designing a sort of big integer, 2 integers or 128-bit integer or something like that.
No, in the value case, I get it. So I'm in general, no Java programming case. Because in the internet, I say, okay, there's a problem with null pointers and nulls. And I have to say, I didn't enter such a problem. So if null pointer exception happens, I think it is fairly easy, to find out the problem. It's not like this is a huge problem.
Correct.
So threading was problematic, and everything else was more problematic than the null pointers. The null pointer was never issued to me. And even now in the last 2 years, I think there was a JAP which improved the null pointer exceptions. And I took a look at the Java libraries, how they deal with specific validations, input validations, and often they say, okay, I don't care when null pointer exception happens. In the Java SE libraries, if you let's say name.length, and they say, okay, if name is not null, if name is null, we get null pointer exception. And what I did all the years, I try to create, checks. If name equals null, throw
Right.
new illegal state exception, and this is what or illegal argument exception. And usually in Java, this is what they don't do. They just say, okay, it happens. And I also started with it and got, good experience, because what happens, I get a very, very nice error message. It says, okay, in this line, something wrong. So I would say this null, it's not a problem at all for me. So I just ask, but I completely understand that we need it, and it is nicer, but it is not a problem. This is not a huge problem like reactive programming, threading, and
Right.
this is a small thing which is annoying, right? So this is how I see this.
It can be in the local. I think in the large it's actually quite pernicious, because null pointer sections can occur at times you don't expect in production, and it stops things. And it's just not clear to the developer using the API that whether they should pass null in or not, there's ambiguity there. And then you layer this on top of layers of APIs, and it can percolate through at any point. Now, the exception, Jet with the exceptions, is fantastic because it helps root cause the problem.
Yeah.
Because you didn't know where it was before, or it was harder to find out.
Now I got you. If we get value types with null, we get more expressive APIs.
We do, and reference types.
Okay, this I'm with you.
Reference types can also opt into it too. They can say, I'm a reference type, but I'm not allowed to be null.
Yeah, this is perfect. So of course, this is huge added value. So because you will see on interface level which can be null and which not. So now okay.
It's like have you heard of JSpecify? I think it's an effort, and they have annotations at null, at non-null.
And IntelliJ as well, not null, right? So this is JetBrains.
Yes. So it's a bit like that kind of mechanism.
So I'm with you. So then I'm 100% with you. But even without, without annotations and language support, it was not a huge problem for me. And
you can get by. We've been getting by for decades on this, haven't we? But I think it's going to vastly improve the stability and the design of things.
Actually, I think in C++ I got segmentation fault, right?
Yes, you might.
Yeah. This is and in Java I always got in null pointer, so I was happy. The first two years. Oh, this is nice. Actually, I get something readable.
That's right. Yeah.
So, how far are we with Valhalla? So we will get, in Java 23.
Good question. I can't really give it. I'm reluctant to give timeframes in case I'm beholden to them, but we're closer than ever before. I think if you look at the first Jet that's ready to come out soonish, is Jet 401, value classes and objects. And so we're actually, it's still work to do, but I think the model that as we've come about now is actually pretty good, and we know what to do for the first bit. So it's just executing to get that first bit done. So it's going to take I don't know, another 1-2 releases. I'm not sure exactly when it will be ready, but it's actually on the sort of ramp down.
Okay.
In terms of, and on the ramp up in terms of, we think in terms of that. Now, something could blindside us, as we go through this, but I think we're pretty confident on where we're heading now with that, and to start focusing on a strategy of integration of the first bit.
Yeah, good news.
And it's not going to be everything all at once. It's going to be split up into separate pieces. So the first bit will give you some degree of flattening on the stack, and I believe the methods, but it won't give you full heap flattening on these things yet. It potentially will give you optimizations for boxing as well. You have to look carefully into that. But the first bit will give some benefits of flattening on the stack and methods. And then we'll go from there to for the heap flattening. Ironically, the VM has had a heap flattening for quite a while. The challenge is the programming model that the developer has to opt in, so they're very aware of what's going on in terms of the mental model they have that enables a VM.
So what should they do right now to get, the flattening advantage?
They can't, except just code in primitives or go off heap. Using Panama or something like that. That's the way you do it at the moment. And so you distort your APIs, of course. Everyone's done it to get that. So that will come later to expose out that model.
What are the potential performance gains?
I think, for example, We have a prototype in the Valhalla branch to add Float16 support.
Mm-hmm.
And we want to add that as a value class. We don't want to add it as a primitive. And so we'll be able to have arrays of Float16 values that naturally are flat. And then you can interoperate easily with machine learning models that have Float16 in them.
Exactly.
You can operate in Java, or you can operate in there. The advantage of having that class into the platform as well is we can enhance for hotspot to also understand what this type is, and then generate efficient instructions when we operate on it as well. So we can encode that, and we don't have to add it as another built-in type. And then developers can do the same outside for their own purposes. It might not get as optimal as that, but they could define their own flat type, I don't know, int128 or something like that. They may not leverage all the hardware instructions, but they get that array flattening, or they can define their own structures for RGB, Z, or whatever, in computer graphics or something like that, and get that flattening on Heap too. So I think a lot of mathematical cases and maybe graphical cases are the things that pop in my head. But I think anywhere where you have a tuple-like thing is a candidate for thinking about this in this way.
But the Float16 thing for machine learning is a huge. I think this will be huge performance impact, right? So
I think it will when you're doing these operations in Java and loops. I think it will help greatly in those cases. It's a significant amount of work to add all that support in, but the chips have the hardware instructions for it, both scalar and vector, and so we're working with Intel to explore what all that effort there.
And something like we will get unsigned int or something like this, or
we may be. This is interesting. Now this opens up a whole design field of what primitive like mathematical types do we want in the platform, and what is their relationship with each other, and can they participate in operator overloading like existing primitive types, built-in primitive types. So it's a whole Valhalla opens up this whole space of design around this area, to which sort of pushes forward the ability to express sort of more easily write mathematically orientated code in Java, like you could do in MATLAB and people do in Python today. That's an area that I'm just thinking ahead.
Yeah, the unsigned int. Why I ask is because I had to do some encryption stuff, and it's everywhere. The unsigned int is everywhere. It's a little bit annoying because you have to use the integer with unsigned, and you have to calculate it by yourself. And if there will be Java support, also a little bit nicer.
Yeah, I do agree with that. It's really awkward to code in it. So there's unsigned integrals, maybe a thing. Float16, Float8, who knows? Maybe we can retrofit or rethink big decimal and big integer in certain ways as well. I'm not sure. But there's a whole, or complex numbers, and complex numbers whose real and imaginary are a Float16 or float or double. You can think even ahead like that. And even arrays of these things where the representation in memory is even off heap. So you get zero copy between Java and native, perhaps, which means you have to rethink the array abstraction as well. So you can see you pull on the string of what Valhalla starts, and you can go, oh, there's a lot of design work potentially ahead here. How do we do all this? So to be continued at a later date in terms of divulging what that might mean.
How often have you changed the direction during the project? So 10 years, was it like was it like straight path, or say, okay, this is
no, it's certainly not a straight path. There's a lot of hill climbing. It's looking up the hill and seeing there's another big hill in the yonder distance. We have to go down and go back up again. There's a lot of I wouldn't say dead ends, but when you're doing research, you hit a point where you go, this is not right. I have to backtrack and go forward this way. You're backtracking, learning what you already did to inform where your next steps are. So there was a lot. I haven't been involved in all the details. Brian could give a much more detailed answer to the explorations, but you can get a sense of it looking back on JVMLS presentations on the explorations. I think something to learn here that we've found is that often when we try and do this, first of all, and it may make sense, first of all, is to try and do something new that doesn't fit in with the existing constraints of the platform, and it may break compatibility. But to think the problem's so large, sometimes you have to think like that. And then when you come and try and fit it in, you go, this is not going to work. How do we fit it into the platform? And so there's a lot of that going on, a lot of that design and thinking going on. And that same kind of thinking also happened with virtual threads. Initially, we thought we needed a fiber, completely separate from thread. And then we go, no, this is compatibility-wise. Can't we just make it look like thread and behave like thread in many ways? And eventually it did. And now we've managed to do this with Valhalla with objects. So things are objects. Everything's an object, whether it's a value object or a reference object. They're all objects. And so the developer doesn't need to have that that bifurcation, if you like, in their head. They're all objects. They're all references. It's just some kind of references are not what you think they are in terms of how they behave. So that was a big clunk. And then we needed less additional bytecodes that are added to the platform. In fact, we believe we can reuse. There's very few bytecodes that will be created with Valhalla. I can't remember all of the details, but originally there was a bunch of new bytecodes added, and then it just got stripped away. So that's that kind of thinking goes on.
Actually, could you write the Java code in bytecode?
Could you write Java code in bytecode?
You.
Oh, you mean write a program in bytecode?
Yes.
Rather than typing
Hello
it
world.
into scripts.
Will you manage to do that?
I have done it on a few occasions, but I wouldn't recommend it.
It's a funny story.
Do it.
So, I don't know. At the beginning of Java, I got lots of requests, from clients. Which IDE should we use? There was Sun Studio and Semantic Visual Cafe on JBuilder, and I was once I made a joke and I said, okay, I don't care because the compilation takes too long, so I write just bytecode and hash. You just write cafe baby and you are done, and then you can adjust. Then you can, if you know a little bit assembler, you can just write. There's not a problem, and it is very productive because you don't have to compile. And Noah laughed, and then I got an email, and they requested a workshop from me, to deliver a workshop, how to program in bytecode without IDE. And and I said, okay, sorry, this was a joke. I have no idea how to do it. I just and they were a little bit angry with me. But so this was my story, which happened maybe 20 years ago. Now we have you can pick whatever IDE you like. But I thought that you're actually able to write bytecode.
You have to know about it in the job we do. It's unavoidable, and it's important to know about it. It's what the VM eats.
Yeah,
and the compiler produces it, and the VM is exceptional at optimizing bytecodes.
Another question. So there are languages like Scala. They have kind of value types, right?
I believe they do.
Yeah.
Language level. Yeah.
But they have a language level, but they cannot optimize it a lot. Because
correct. They would benefit from Valhalla as well.
Yeah, exactly. This is what I thought, because it is nice to have that 2 levels up, value types, but at the end it's the same bytecode as Java. I would say it could be even slower than Java then, right?
It's hard to say. I think Scala has quite a sophisticated language translation strategy. So the bytecode.
Okay. Maybe they
but they can still leverage generate the bytecode and put a flag on the class to say this is a value class. And in fact, prior JVMLS's, Java VM and language summits, there have been people from the Scala language group who presented working out what it might be to use Valhalla with notions of value types. So I think it's entirely possible to generate the bytecode with the right information in to tell the VM this is a value class.
But not now, later, right?
They could prototype it. They can use the Valhalla prototype, but it's not
now, what I mean right now, so if they know a language which is not Java, which has value type, runs on JVM, so such a language could be slower than Java itself.
Yes, in that potentially, if it depends on the translation, but if the values are all coded as reference classes underneath, then it's and mental model of the language developer is these values will be flattened. They'll be sorely disappointed right now.
Yeah.
Unless there's a crazy translation strategy somehow that
this
it up.
This is what I meant, because I know I get off arguments, hey, the Scala value types or whatever. So but I don't understand how it works, because the JVM doesn't know about that. So maybe you can somehow optimize it, generating ugly bytecode or whatever,
yes,
which executes faster than my records or enums or whatever. But I still don't get the advantage.
No, you won't get that. You'd have to have an alternative code gen strategy.
Okay. So, pretty cool. So we covered, I think, or we missed something from Valhalla.
Vector API.
Vector API.
I was going to connect it to Valhalla. So when the first bit of Valhalla comes out, we think that will unlock the ability to also preview the Vector API as well, because the vectors will be values. And vectors are values that predominantly live on the stack. And then eventually they're compiled down to vector registers. So it's actually quite perfect that it unlocks that. And so we may be able to ship the Vector API when or sometime after the first bit of Valhalla comes into play. To be determined, but we think that's what the first bit of Valhalla will unlock for us in that respect, is to be able to do that.
This could be also interesting for Panama, right? Because if you say we have new value types, let's say Float16, whatever, you could map easier to native, or how to call.
Yes, if we add a Float16 type, we need to have we can map that as the carrier type for the native Float16 as well. And if we had arrays of Float16, we may need to specify that this array can be passed with pinning or something like that without copying. We have to probably specify just like the fact that the J and I in Panama, when you have an array like an int array, it just so happens that it's format that C has and conforms to the ABI. And it's a happy chance because it doesn't have to, but it's the only sensible way to do it. So an array of Float16 or floats, the only sensible way is to keep it in the IEEE format in a way that C developers would expect, so we can interoperate. But it would be complicated to interoperate generically with any value class natively, because in general, the hotspot runtime controls the layout. It wants to optimize the layout in any way that it wants. It's not going to conform to the C ABI in the layout at all. So if you've got your own value with your own fields in there and you want to interop natively, you're out of luck. You're going to have to translate it yourself. But for certain primitives, I think we've got a good chance of defining that interoperability.
We briefly talked about Vector API already, and in the previous podcast. But why we will need Vector API?
So if you want to take full advantage of the hardware of the CPU and reliably, you can use these special instructions, which are called single instruction multiple data, which basically means is a little parallel processor in the CPU. And you can take advantage of that and write code to that. But if you want to do it reliably, you have to write in a slightly strange way. Compilers can generate similar code for certain things, but they can't determine everything. And they can't determine it reliably. So the Vector API gives you that extra power to write data parallel programs explicitly. You have to sort of distort your programming in a way. So it's not meant for every developer. It's more meant for advanced developers who are writing highly optimized libraries that expose out something for other developers to use. That includes the JDK as well.
You know Jose, right? From the Oracle Java team? Jose, the French guy. Jose Pomard. This is
yes. Jose.
No, not Jose. Jose. I had a podcast with him. He said it's French. I called him Jose. He's like, no, I'm not the Spain. I'm from French. Jose Pomard. And he had done a great talk about Vector API DevOps, and he did it a lot. So also interesting, for the listeners if they would like to learn about vector
Yeah,
API.
I mean that's it. I mean it's not something I'd expect most developers to use at all, but it's something that unleashes a lot of optimization capabilities. If that's your in writing certain data parallel algorithms or mathematical algorithms, for example, you can write an arctangent function vectorize, which performs extremely well compared to as long as you're willing to forego some accuracy of the existing API, it can work really, really well. And a compiler would have a hard time taking Scala code and translating that in a way that's optimal. So you can do stuff like that. Also, we're going to work with a vector API in Float16 as well. So we'll have vectors of Float16 too. So we'll try and bring that together as well.
But a vector API, I think, is available in preview, right?
It's incubating. It's been incubating for at least 4 years now.
4 years. But is it usable right now, right?
Oh, it is, yes.
Because I saw code when someone read with Vector API this Olama model in Java 21.
Yeah, I think they were doing the dot product, didn't it? Yeah, with the vector fused multiply addition, fused multiply adds vector multiply adds, which you can get some good speed ups doing that.
Okay. Perfect. So we covered lots of exciting stuff. And you are working mainly right now on what? On Valhalla?
I'm doing Babylon stuff.
This is your...
So I'm doing that. And I'm also thinking ahead what it might mean when, as I said, when Valhalla sort of opens up this whole new area of possibilities around new value types and their relationships between each other. What does it mean for operators? What does it mean for arrays of these things? How can we have tenses of these? So I'm thinking a little bit about that as well, in connection with Babylon, but also just pushing the platform forward. I mean, if we can get equivalent Python-like capabilities for writing machine learning models in Java, I think that would be outstanding. It'll take us a while to get there, but I think that's an interesting prospect.
But why is Python better? Because Python just calls C, right? So what they do just expose C API more or less.
I think Python, it's a lot of people who weren't programmers, but more like mathematicians, statisticians, scientists picked it up because for similar reasons they picked up MATLAB. That they could write expressive mathematical expressions that are easy to read and maintain. And I think that's Java struggles with that.
Yes, right now, because it's type safe and more complex or chatty, right?
Whereas in Python, it's very malleable in terms it doesn't care what's on the left and right of the plus in compile time.
Yes.
But when you write it, it's only when you hit it at runtime it does, and it works it out dynamically.
Like JavaScript, but it doesn't mean that. I mean, if we are done with Valhalla, it won't improve the situation. I think if we get the pattern matching and record deconstruction, this will improve the readability maybe and make it almost like JavaScript-like.
That the pattern matching will improve readability for other things, but if you add a float16 in, you can't do f plus f16 with a variable of float and a variable of float16. You can't express that, so you'd have to express it as a method call. And so that has implications.
Okay.
And it's same applied for arrays as well.
So now I understood. So what Python can do, they can just have operations on data types which they don't know about, right? So
yes, it's like operator overloading.
Yeah.
I'm wondering, what does that mean? Because Valhalla will add all these new primitive types in, potentially inside the platform and other people outside the platform. So how do those, if they're mathematically related, mathematical types, how do they relate to each other? And how can we add something in like float16 and get it to feel like it's a float in terms of what you can do with it? So Valhalla will open the first bit of that up, but there's more to do in terms of making it be like codes like a class behaves like an int.
And operator overloading, this is like happens behind the scenes, right? So it's not like we get it. So it's just more like you said equals is like a structural comparison and plus
for values, but plus I think we have to think about this in a way that we don't hard code it into the language and specification, but we add it as an extensibility so that it becomes a library extension.
So I could use operator overloading for something else?
Potentially, as long as you don't abuse it.
No.
Which is actually damn hard
I
to
always
do.
abuse operator overloading.
Yeah,
I really
think
like,
that's-
the
yeah,
C++ for that. I try to
yeah. I think
overload
there's
everything at the beginning,
this is a challenge for readability, but maybe there's ways to do it if you focus on the operators associated with, and they have to be numeric types or something like that. What's a numeric type? We don't know yet. It's certainly not number, but we need to I think we need to redesign the a sort of numeric hierarchy of relationships between various numeric types, make it richer. So you can then slot in the notions of what is addable, what is an arithmetic type, and what properties is an arithmetic type. Well, it comes with addition, subtraction, multiplication, and division, perhaps, or maybe there's a way to factor it out more mathematically. And once you have those notions, you may be able to devise something similar to what Haskell has with type classes, and then use that concept to, or C Sharp's extension methods. So, this Valhalla motivates all this kind of thinking. And I've been pondering it a little bit, trying to get ahead of it.
Now I understood a little bit better. So what is said, if we have primitives, and in Valhalla is going, the primitives will behave like classes, and therefore we could potentially define, plus, minus, and whatever meaning of that, and have extensibility there, right? So this is the entire trick, because if the primitive becomes a class with no performance penalty and then I could, of course, implement method add subtract or whatever, and then the next step would be, okay, then in this specific case, plus will call behind the scenes, the method add or whatever.
That's correct. I think you've got the general abstraction quite right there. So the challenge is to devise that extensibility and not hard code the classes in the Java language specification. There's this big 9x9 table of conversions between various primitives references. We can't add Float16 and make it 10x10 and then add unsigned int, make it 11x11 in an extensible way. This is what Guy Steele calls growing the language. So how do we grow the language? And so libraries can participate. And I'm seeing this, leaning into this, how we grow the language for libraries like this. We're leaning into it with Babylon, to how to grow the language so people can write GPU support as libraries as well. So I think this is a very powerful way to build and grow a platform.
Yeah.
So we provide the primitives and the mechanisms, and we grow the language and platform that way. And so the challenge there with Valhalla is opening up that. We don't know what it is yet. There's more known unknowns than anything, but I think we can start looking.
Potentially, we could use Babylon for operator overloading, right?
Well, you could. That's one part. You can fake it, and you can say, actually, these ints are not ints; they're something else.
Yeah.
That's kind of a poor man's operator overloading, but it works. I think we can use Babylon. If we abstract out arrays, we can use Babylon to optimize the kernels that you specify for operating on arrays. So if you have two tensors coming in and you describe some element-wise operation between the elements, it's going to be a scalar. We can look at the code and then generate automatically some GPU code dynamically, or generate vectorized code for the CPU using a vector API. And so we previously termed this cracking lambdas. So you crack open the lambda and look at its code. And that's where Babylon will come in here for optimizing these cases. So it's another interesting connection between various technologies.
Perfect. So great times, I have to say, right?
Yeah,
so,
it's
perfect
quite
storm.
exciting. Yeah, future's bright.
So I have to admit, at the beginning of my developer time, my idea was to learn as many languages as possible. And then I said, okay, then, by accident, I started with C++, and then with after Oak, Java 1.0. And then I'm learning the entire time, and it's never boring, This is Java, this is an endless, never-ending story. And, recently, enums and records are somehow, similar. And now you are coming with entire new world. So if you're done with Valhalla and whatever, I also will, of course, try to use it. And what means that actually we will never learn another language because there will never time, because Java is too exciting. It's actually never time to learn something else. So you should stop, the entire research in Java land for a few years. So I will have time to learn Rust or whatever. But right now there is actually absolutely no time, Yeah.
I suppose that's winning in some way. I think every language is learning from all the other languages where we sit. Like I just mentioned Haskell or Python or MATLAB, or even APL or J. There's lots of interesting input there, and we can learn it and then translate it to the Java world for all the Java developers. So they can choose not to learn another language if they don't want to, or they can
or no time. Actually, I learn all the time and still no time for all the years. Like, okay, maybe Oracle could stop innovating because then would be a quiet time.
No, that was like yeah.
And lots of new ideas. If I talk with you or listen to the Oracle,
there's no shortage of things to do.
No,
I think the challenge is to prioritize and work out the steps to do things.
But now I understood why Valhalla is so challenging. The last part with operator overloading, whatever, because for me as Java developer, it doesn't occur to me, so okay, let's do it, value, and it's done, right? What you're doing in 10 years, but it is actually a huge problem. If you think about this, it is not easy.
I mean, it exposes out another sort of seam, if you like. We're closing the seam between int and integer. And once you do that and someone can add their own thing, there's another seam like that, and exposes out seams with arrays as well as we keep pushing and pushing, and we'll just slowly close those seams together, make it a better language and platform.
Perfect. So where people can find you, Paul?
What do you mean? Where? In
the social media, internet?
I'm actually not on. I know you sent me a Blue Sky invite, but I haven't responded to it.
You don't need it anymore because you can just, register if you like.
Okay.
And Blue Sky is actually a nice community, really. So there you will recognize lots of folks from before. It looks like Twitter, but it's somehow nicer.
Yeah, I need to get back on after Twitter. As I said, I stopped using Twitter for obvious reasons. And going somewhere that's not run by a no, I won't say. I'll hold off on comments.
Yeah, but Blue Sky, what you could just do, you just post, the reference to Valhalla, whatever, and you are done. And from time to time, do something and make more.
The best thing you can, the way you find me or what output is through inside.java probably at the moment in terms of output, and that's where you'll hear updates right at the moment.
Perfect. Thank you a lot. It was lots of fun.
Yeah,
and
again.
Yeah, and I learned a lot to know why Valhalla is so complex. So this is now I understand more. So
we just scratched the surface.
Oh, thank you.
Yep. Okay. Bye bye.